Hello everybody. Today I'm going to go over a Bally Midway linear power supply. This is the one that came out of the Seawolf that I repaired. And I have recapped this board and kind of flowed the connectors, the header pins. But that's really all I've done to it is recapped it. I haven't replaced any of the transistors or the regulators or anything like that. I am going to do that, but first I want to test this. I want to wire a transformer up to it, put this thing under load and test it out. But I figured this would be a good opportunity to kind of go over the schematic with you and look at this, how this is working, how it's wired, the different circuits that are on it, and how to go about diagnosing this if yours is not working. That's kind of the point of this video. So let's zoom in a little bit and just kind of go over some theory of how this is working, what it's doing. Let's go right there. How's that? Okay. We have a transformer here. It's got one primary winding, and then it's got a bunch of taps off of the secondary. It's got a center tap with multiple taps. It's got a 9-volt tap, 12.5 volt tap, and a 14.5 volt tap. So from here you have center tap to 9, you have 9 to 9 is 18, center tapped, and then 12.5 and 14.5. Let me just make sure this is all in the shot. It's hard for me to see this, to be honest. Okay, here's our transformer winding. Yeah, okay. Yeah, that's our transformer. Let's go right there. And then you have a second secondary winding, and just a 12 volt winding that looks like it is used for the voltage audio and the voltage ground. And you have 2 diodes here which rectify both sides of this, full wave rectification, and then you have unfiltered going here, and it says VIND around 10 volts RMS at 3.5 amps, and then you have a diode here where that same rectified is going through, but it's just blocking it from this. It's just separating this diode. The purpose of this diode is to separate these two lines, the current path. And that is filtered with 4,700 microfarads, and that is the audio voltage around 13 volts at 1.5 amp. And that 1.5 amp is going, that's derived from this diode. This is probably a 3 amp diode, so it's not going to let it go any more than 3 amp before that diode goes bye-bye. Okay. Yeah, display lights are off of this 12 volt as well as voltage audio. Okay. Center tap is the ground for the whole system. And we have 9 and 9, I would imagine, is rectified for the 5 volt circuit. And it goes through here, and you have diode here, diode there. So it is full wave, but they're only rectifying the upper portion of the sine wave for the +5. And then you have 1 amp diodes down here rectifying the negative going part of that 9 volts, and that is setting the ground for this. And that's also, that is not setting the ground, that is the -5 volt supply, because here's your 7905, so that's inputting the 7905. Okay. Alright, the 9 volt comes in through here. It's rectified right here, these two A15Fs, and then it's filtered with 20,000 volt or 20,000 microfarad, and that goes to both the collector of the pass transistor and goes to the input of the IC, the controller IC, which is basically a UA723. Okay, and then that's the pass transistor right there, which is being controlled by that chip. The base is being controlled by that chip, and it's allowing, depending on whatever the load is over here, this controller is turning this transistor on to allow current to flow to the regulated 5 volts. Current sense resistor right here that is sensing the current for that chip. Okay. This is our reset circuitry right here, these 3 transistors. And it looks like if this transistor, this is going to be ground right here, there's that center tap line. So if this transistor is turned on, it's going to pull this reset line low down to ground to reset. So this would have to be a lower potential on the base for it to not be in reset. And that is pulled up to the 14 volt rail on the collector, and that's connected to there. So as long, okay, that's going to have a positive, so this would have to be turned on to pull this low to keep this one turned off. So this one would have to be on, this one would have to be off for it to not be in reset. Just kind of quickly looking at it, that's kind of the way I'm looking at that. Yeah, so you have a couple just regular old regulators here, 7812, which is off of this 14.5 volt. See, this other 14.5 is going to come up, and they're rectified right here with these A14F. And those are probably 1 amp diodes, I would think. Maybe 3 amp. And yeah, probably 3 amp. And then there's your regulator, which this is a typo actually. Okay, in, common, out is what this is. So this should be 2, this should be 3. Let me zoom in a little bit. Okay, and we are right here. We're right here. Right in the center there. Okay, yeah. Hopefully I keep this all in frame. I just got to keep it right around in this area. You have the input right here. You got this coming in, input. Then you got your common right here, which is going to be 2, and then the output is 3. So this is actually a misprint. And I actually did look at that on this board, and yes, this is misprinted. So yeah, 7812 is 1, 2, and 3 is in, common, out. And the common pin is actually through a pot and resistor network right here. Let me scoot this up just a touch. And I'm going to back that. I don't like that being like that. Okay. Hopefully you can see this. Anyway, yeah, there's a resistor and pot network right here that basically biases the ground pin. How these 78 series, 79 series regulators work, they can work as a...
Okay, I found this on the wiki.
I said series and my phone turned on. Siri. But yeah, they can work as a fixed regulator, or they can be a variable regulator with this resistor network on the ground pin. So you can vary that voltage output. So yeah, all 3 of them have that. This 7808, and that's what they're using for the 10 volt line, is a 7808, and then they just dial that in. And there's the 5 volt, and down here is the 7905, and that one's also wrong. This should be the pin out on one of those is actually Pin 1 is common, so that's correct. 2 is in, so this should be 2, and this should be 3. So in, common, or common, in, out. And I was wondering if these parts were just different or whatever, and I did beep these out and look at it on the actual board itself, and it's just a typo. That's all it is. So that's really, I mean, that's about it. Then you do have this 12 volt tap right here, and let me kind of back up so that we can see that. You know, there's this 12 volt tap. Yeah. The 12 volt tap I'm not worried about. We don't need that because all that is you got the two 12.5 volt lines come up here. They get rectified right here, filtered right here by the 4700, and then they run off to do something that's not, it's not on here. So what do they do? I don't know. You know, right here, way over there. It's not labeled. Yeah, they come up here, rectified, filtered, and then it just runs over here. So I don't know what the 12.5 volt does, if it does anything. So all I'm worried about, all I'm concerned with is the center tap. You have to have a transformer with a center tap, and then you need a 8 or 9 volt tap, whatever, and then a 14, 15, 16 volt tap. And I do have a transformer that will work perfect for this. It's a Midway transformer, and I believe it's got 9 and 16 volt with a center tap. So that's what I'll use to wire up to this thing right here, to wire up to this guy. And test this thing out. As you can see, I've replaced all of these capacitors. I have not replaced the voltage controller or the pass transistor or any of these regulators over here. I've tested all of the diodes, and they all test okay. Fuse is good. These are all original pots. This had some tantalum capacitors on it that I replaced with electrolytic. They're just filtering. And actually, let me look at that schematic again, because I want to look at this. Are there tantalums on this? As if there are. Voltage ref. No, I don't see any tantalums. There's a 100 picofarad. Okay, if there were tantalums hooked to this guy, then I would have probably replaced these with tantalums because it's kind of critical. So, but I don't see that. I don't see any. When it comes to these guys, these UA 723s, if there are like this compensation pin, if that happened to be a tantalum, you would want to replace that with a tantalum capacitor. But there is not. It is not done that way, so I'm not worried about it. Okay, yeah, so we will go through this thing. I'll load it up. You know, we'll put loads on it and we'll test and make sure we can adjust things and kind of go over that. I think I'm going to replace these anyway, but I want to see the condition that it's in. Would this have worked? If I just recapped this and sent it back to the customer, would it have worked? And if it does work, how long would it work with old regulators, right? So yeah, let's go ahead. Let me get the transformer out and kind of wire that thing up. And yeah, test this thing out, see what we got. Okay, now as you can see, I've got this old, quite ugly Midway transformer. It's an MT58, and if we come in and view it, that's the primary. These white wires are the primary coming in, and you can see this does have the 012, has the 0 and 12 volt, so this would actually work for this. And right here we have, if I get this out of the way a little bit, if we can, I might have to come down, and I may have to do this freehand. Come down and look, we have a 0 center tap, 2 9 taps to the sides, and then 2 16.5 taps. So there's our taps that we need. So I will wire this thing up to this guy to plug it in. And next shot we'll come back. This should be wired up and we should be ready to do some testing. Okay, so we're ready to fire this up. I've got the transformer wired into the supply. I've got my current limiting hooked into the variac, and then I've got the transformer plugged into the current limiting strip. So, yeah. I'm going to go ahead and turn the strip on. It's in current limiting. I'll turn the variac on. And I'm going to bring the variac up to about 45 volts. And the light is starting to come on the current limiting. We'll go up to about 75 volts. Let's check the input voltage coming in on the transformer. I'm on AC, right? Yeah. Let's see what we got. That's the 9 volt, so we have 6 volts on the 9. And then over on, this is 16.5, we have about 12. So we're getting there. We're at 75 volts AC. Let's take it up to 90. Alright, now we're at 90. And the current limiting bulbs are not on at all, which is good. So I'm going to go to, let's check our AC, or DC voltages. There's 10 volts DC, and that is the 9 volt tap. And here we have, across this cap, 17 volts. That must be the 12 volt. And yeah, 9 volts. I think that's the -5. And okay. And let's look at the output on the, what is this? 78. I don't know what that is. 1 volt. Okay. Negative, that's probably the -5. This must be the 7808, and it's at 1.8 volts. The collector of the 3055 is at I'd have to look where the emitter's at. This is the 12 volt regulator. Alright, let's take this up to about 105 and about 115 volts. Right there. That's about 115. So this thing's at full line voltage. And the current limiting is not on at all, which is good. so I'm just going to switch to bypass. And now this thing has full. This is the common. But this thing doesn't seem to be doing anything. 10 volts out of this, which is $10 out of that, and that is the -5. Okay, common input. There's the input and the output. -5 volts, perfect. That's the -5. 7814. What is this? Oh, okay. This is the 7808. So it's input common. That's the input, which is nothing. Pin 2 is ground. And nothing. This one isn't doing anything. And this is the 12 volt. So this should be input. And our output is non-existent. 12, see the 12 volt? We have our input voltage, but this is the output. Nothing. How about 5 volts? Where is testing 5 volts? Let's look at this. Where's that current sense resistor? 5 volts is 19 and 20 on this thing over here. So let's find the ground. Common is 16 and 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Through 17, 14 through 15. Okay, common. And the 5 volts is pin 20. So don't want to be shorting anything now. That is 5 volts right there. Now let's see, can that be? Where is the adjustment pot? Look for the 750 ohm resistors and the 470 microfarad cap. Right here. I think this one's it right here. Let's see what that did. Yeah, and we got way too much going on here. So we're not regulating 5 volts. That's way too high. It should be better than that. So that's probably this chip. We probably need to replace the UA 723 for. I'm going to replace all these regulators. We saw that 2 of them are no good. I want to look once more at the 7808. Is it even getting an input? The 7808. In. It's not even getting an input. Well, let's find out, where's that coming from. That comes from 11 and 10, which are those two. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me turn this down. I've got it hooked in the wrong spot. Okay. I'm going to go back to current limit. I had it hooked up wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Yep. Okay. It didn't harm nothing because I had it in another winding, so it just wasn't doing anything. It didn't hurt anything. It just wasn't doing anything. So now that it's hooked up right, it's in current limit. I'm going to turn it back up. Let's go straight to 60. And over to 75, nothing yet. Go to 90. We're at 90 volts. Current limit, lights are completely out. And full line voltage. Okay. Yeah. So let's try this again. Common input. Still no input. Output. Oh, let's kill the current limit. No voltage in. Okay. Let's just make sure that we have voltage coming in here. Okay, there's one side, there's the other side. Okay. Now let's check our rectified. Nothing. Nothing. So it looks kind of like we might have bad diodes. Let's go back here. Do we have anything on here? How about here? Okay. There's 20 volts DC. Is that where that's coming from? And the 9 is probably right here. That's 20. Yeah, the 20 is the both sides of the 9, so 10 and 10. That's probably this right here. And then I should have 30. I should see this somewhere, which is 36.9 volts. I should see that on these diodes too somewhere. And I'm just not seeing it. Where's that going to? That's 20. That's not it. That's not it. Alright, this is very strange. Let me cut away for a little bit. I got to find out where is this 36 volts? The 18 and 18 from the 16.5 volt tabs is right here at the pins, but I don't see where they're going to get rectified. That is for a positive voltage. It has to be here maybe? No. Nope. Alright, I gotta figure out what's going on. Let me figure this one out. Find out, follow those back to wherever they're going. And I'll be back. Okay, and after further review, I found that this schematic is not very good. So there was an extra... The schematic has it drawn as if the 7808 circuit is shared with pins 11 and 12 off of the transformer. You see where, let me grab a pin. See where these that 14.5 volt is rectified here and is shared here with the 7812, and then comes up and then puts the 7808. In reality, there's actually two more pins over here, 5 and 6, that come up and are rectified by two more diodes on the board, and then that comes over and actually inputs the 7808, and this is not a connection right here. Yeah, so 5 and 6 right here come out to right here. The anodes right here and here. And then that in turn goes off to the 7808s. And the 78 right here, the 7812, is powered by this set here, which runs all the way over here and is rectified by these two diodes on the side over here, and then it runs to the 7812. So now I had to put another AC line in. I just put another tap in on my 16.5 volt taps to come over here and get rectified, half and half. So it's 16.5 here, 16.5 over here for the 7808. So we'll go ahead and fire this thing up and then do some more testing, and hopefully we find out a little bit more. That 5 volt's definitely bad though. Okay, so I'm going to go ahead and turn the transformer on. Okay. I don't see any light. There's no lighting on the current limiting, so go ahead and give it full voltage, line voltage and current. Now let's check our 7808. Here's ground, and here's the input voltage. And there's still no input voltage. How about this guy right here? Oh, I'm on AC. Let's try that again. Okay, there's input for the 7808, and our output is no output. So we have voltage in, we have no voltage out. Okay. How about over here? This is our 7812. Here's in, and here's out. And there's nothing out. Let's try messing with this pot. There's no output there. -5, I think we already established that it was okay. Let's just look at the output. In, that's common. That's not the -5, is it? Yeah, it is. -5 is common in and out. Yeah, -5. That's good. There's only one of these that are good. And then you got common. Here's input for the 8. I got more voltage on the 8 than I do on the other one. But it's actually the same tap. That one's dead. And then we have in and out. This one's dead too. So the 12 volt's dead. And of course our 5 volts is also dead. Our 5 volts is just too high. So this is common. And 5 volts is right here. Right? Three, 4, 5, 6. Yeah, I don't know. I'm getting nothing out of 5 volts now. Alright, let me shut it off. What's going on? Is this thing dead or what? I got it hooked up correctly, right? Yeah, 3 and 4. That's right. These two go off to there. That's good. Those two go off to there. Yeah. Yeah, so this thing's got issues. It just doesn't work. So I'm going to have to do some rebuilding. I think this thing just totally died. It was giving me 7 volts. Now it's giving me no volts. That little chip there. So we're going to have to replace some parts on this. And then come back to do some testing. The Bally Midway power supply has been rebuilt. You can see there's a new 3055 pass transistor, a new -5, +8, +12 volt, plenty of grease. I'm a firm believer of grease them up with the paste. This chip has been replaced. I took some deoxit, squirted in all these pots and worked them really good and kind of set them at center. So now we are ready to hook back up to our, here's all the old parts, hook back up to the transformer and see if we get all of our proper voltages. Okay, I have the power supply hooked back up to the transformer and we're going to go ahead and test some voltages here. And yeah, that'll work. So let me go ahead and fire it up. And we are I'm going to go ahead and put it in current limit. And let's turn it on. And the current limiting lights were way high. Into something's shorted, something ain't right. Oh, I know why, because I got my desoldering gun plugged in. Let me unplug that and turn it back on. Okay, there we go, that's better. Yeah, I had my desoldering gun plugged into the current limiting too, and it made the light bulbs light up bright. So obviously that thing needs more than just 1 amp of current. Okay, we're now turned on, so let's go ahead and see what we got as far as voltages. This is the -5. Okay, let's do this. Okay, there is the -5. That looks very good. Now let's do our +8. There's our +8. And over here is our +12. And there's our +12. And for our 5 volts, we come down here. And it's at basically 12 volts. There's really no regulation there. And I'm kind of curious about this potentiometer. It makes no difference. It has no bearing on this thing. I mean, do we have a open pot? I'm going to remove the potentiometer because we have no regulation at all in this pot. The way it kind of does is it will, if it's open, you'll get no regulation at all. So, yeah, I don't know. We got to check that out. I'm going to remove this guy. That's why I had the gun out. I'd already checked it. Spoiler. But I wanted to check it with you. Let's go ahead and turn this off. But as we saw, we have all of our other voltages good. So that's good. I've replaced the transistor and all these. I replaced this. And now I'm just, my suspect is this pot. So let's remove that pot and check it out. Because there's really nothing else to it. You know, what I could do is I could put another chip in here just to verify really quick. I'll do that off camera. And yeah, my suspect is this guy right here. Okay, well, strangely enough, I removed all of these pots and they all tested good. They all tested perfect. I squirted them some more with some more deoxit, put them back in the board. Maybe I was just hooked up wrong. I don't know, because I've hooked back up and here's my regulated 5 volts. It's a little high, but I think with the real deal it'll be right. You know, this isn't exactly the right transformer that's made for this. I'm sure it's close, but it's just not quite. I don't know. But anyway, yeah. That's my 5 volts, and then we go through and we can see the other voltages. This is -5. This is the 8 volts, which I'm going to load that and see what happens. And there's 12 right there. Those are all unloaded. So I'm going to go ahead and load those up and see what we get. Okay, I am on the 10 volt, and it is 10 volts. And it's 10.39 with a 22 ohm load. That's this one, right? Yeah, that's this one right here. That's with that 8. They're using an 8, an 8 amp regulator. I'm thinking I might change this to a 500 ohm pot to try to bring that voltage down more. I think I am going to do that. I'm going to put a 500 ohm pot in here. See if we can't bring that voltage, be able to adjust it down a bit more. because that's the voltage supply for the custom chips, and I want that a little bit lower than 10. I want that lower than this at a half an amp. So that is one change I'm going to make. I'm going to replace this 100 ohm pot with about a 500 ohm pot. I might even go up to 1K on that, be able to really dial that down. All right, I'm going to move on to, I believe this is -5. Yeah, -5. We can adjust that up. And that's 5. 22 ohm resistor. Let me see. Okay, 5 divided by 22 equals, that's only, that's not, that's like a quarter of an amp, which, that'll be fine. I mean, yeah, it works. So, okay, let's move on to the 12 volt, which is number 6. 6 and 7. So 1, 2, 3, 4, 5, 6. Okay. There's our 12. And that's that one right there. Yeah. So that's fine. That's 12. That's about a half an amp-ish. Around there, 400 milliamps, something like that. So that's your 12, and there's our 5 volts. That's unloaded. 5 volts is unloaded. Cool. Sync tests okay. I'm going to go ahead and replace this pot. I'm going to up the resistance on this pot and try to bring that voltage down. Let's do that. Actually, this should, if I just flat out ground this, let me think about this. If that, yeah, they're using this as a variable, this 0.8 as a variable pot up here. So if that's just flat out grounded instead, it needs to be closer to ground, really. Yeah. What would happen if I just ground pin 2 on that 78? Yeah, if I just ground that, it should be 8 volts. Yeah. Alright, let me look into that. I think putting a higher ohm resistor in there will make the voltage higher, actually. So let me check that out. Okay, I took the ground pin right there. You see, the tab is ground on that 7808. And that's okay. This is grounded, this thing here, so it doesn't matter if that's touching that. And I've got it grounded. So I'm actually just bypassing the pot and everything and grounding that out. And now I'm getting 8 volts. Yeah. So I'm kind of thinking what I might do, let me turn it off, and that's with this load on it. I think what I'm going to do with this is I'm going to put a 9 volt regulator in here, 9 volts, and then just ground that, just bypass these pots and everything, and I'm just going to jump pin 2 straight to ground. put a 9-volt regulator on there, and we'll just have a fixed 9 volts instead of 10 volts. Because 10 volts is too much for those customs. That was proven, and they re-engineered that after this down to 8.5 volts. Or about 8 3/4 volts on the Gorf boards. So I'm thinking I'll put a 9-volt regulator in the board right here. You know, I might just go with 8, to be honest with you. I don't know. 8 volts. Let's do that. I'm going to do this, and I'll let the owner of this know, because it's better to be safe than sorry. If the video doesn't act quite right, then maybe that the customs don't have enough voltage. But I'll send along in a baggie a 9-volt regulator. And I'm going to leave this one in, and I'm just going to run pin 2, the ground common. I'm going to run that right to ground, so that this is a fixed, this won't have no bearing on it. I'm going to leave that in the board. But this will be a fixed 8 volts instead of 10 point something, you know, going 10 point whatever, going up to those customs. That's just not healthy. That's not going to be good. So I'm just going to ground the common pin, make it a fixed 8 volts, let the customer know that if the video just acts a little flaky or colors aren't quite right, or because that data custom is the video chip. I think it's going to be fine with 8 volts, to be honest. I do. So that's how I'm going to send this back. So let me go ahead and do that, mod that, and I'll be back. And I need to do a little research, because this chip right here is not the same as a UA723 or LM723. It's not. It is different somehow. So I need to this SG3532 is a little different than the LM723. So I'm going to go ahead and do a little research on that and see what's up with this chip. But yeah, so let me do that and I'll be back. Okay, and there is the jumper to ground. You can see here, this is the 7808, and this is the common pin. It comes through here. Okay. To the pot. And then I'm running that to right here, which is ground. It comes through here and goes over to that negative side of that cap. This is the negative side of a cap, wraps around over to here, and that's ground. And that's ground. These 4. So now that'll be fixed at 8 volts at 1.5 amps. So I'm going to hook it back up and make sure it's just a fixed 8 volts here. One more test and call this thing done. Okay, we have the power supply hooked back up. So we will, and I've got the load on it. I've got the 22 ohm load across it. And at 8 volts, that will be approximately 3,500, 3,600 milliamps, something like that. So let's go ahead and fire the thing up. Okay, it's on. And let's test our voltage at the load. And 7.98 volts. I like it. So we have 8 volts with the potential of 1.5 amps of current potential. So I like it. And this says it's the 10 volts at 500 milliamps is all that they're wanting. So, there you have it. Well, I hope you enjoyed this. I hope you may have maybe picked up a tip or two that'll help you in your troubleshooting of power supplies. That's going to do it, guys. Thanks for watching, and we'll see you all on the next Classic Arcade Repair. Bye for now.